This is Geometry 8.4. Today we're going to talk about similar triangles. To review from yesterday, we set up a proportion 40 over 32 is x over 14, and now we cross multiply and solve. 32x is equal to 40 times 14. Can you tell me what is 40 times 14? 560. And then we take 560 divided by 32, and you said 17.5. 17.5. Yesterday we introduced similar polygons. The day before we talked about triangle proportionality theorem. And then in 8.1 we talked about proportions, setting up proportions and solving. Today we're going to focus, if you remember last semester, we talked about congruent triangles. And there were 5 theorems that proved triangles congruent. It was side, 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 angle, side, angle, side, angle, 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 side, and HL. So whenever we would prove that 3 sides of one triangle were congruent to 3 sides of another triangle, we would say that the triangles were congruent by side, side, side. Today we're going to do something similar. Except for the triangle similarity, there are only 3 theorems to remember. AA, which stands for angle, angle, SSS, which is side, 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 and SAS, side, angle, side. Now, they are slightly different from the congruence theorems. The side, side, side with the congruence theorem meant that the 3 sides of one had to be congruent to 3 sides of the other triangle. When we talk about similarity, what we mean is that all corresponding sides are proportional, and that's how the triangles are similar. And then yesterday we talked about corresponding sides being proportional. AA means that 2 corresponding angles are congruent, and side angle side means 2 corresponding sides are proportional, and the included angle is congruent. So this goes all back to the definition of similarity. And the definition of similarity states corresponding sides are proportional and corresponding angles are congruent. So we want the angles to be congruent, we want the sides to be proportional. Take a look at the first example here for AA. Determine if the examples below are similar by AA. If yes, write the statement. What I see here is 2 triangles, and they have they each have an angle of 75. And they have an angle of 31. And then if you were to solve for the third angle, you get 106. 180 divided by 106 would be 74. Can somebody check and make sure that's correct? We actually didn't really have to find a third angle because the name of this theorem is AA. All we needed to show is that 2 angles of one triangle are congruent to 2 angles of another triangle. And we already see that, so we're going to make a conclusion that these 2 triangles are similar by AA. And now we write the statement. Triangle ABC is similar to triangle DEF. Let's take a look at the second example here. This is the one that I emphasized a lot last semester. I would tell you guys, whenever you see a bow tie, what are you going to mark congruent? Do you remember? Whenever you have a bow tie, you label a pair of vertical angles, and what we have here is, this was already labeled for us, so there's 1 pair of congruent angles, and now there's another pair of congruent angles. What's the conclusion? Are they similar? Yes, 2 angles of 1, right? That's what the AA says. 2 angles of 1 are congruent to 2 angles of the other triangle. So we're going to say AA, triangle VXW is similar to. Try to follow the same pattern. Notice how VXW goes yellow, green, no highlighting. So what would that be on the other triangle? So I went from yellow to green to no label. Where do I start on the right one? y, x, right? Z. Let's take a look at question 3. Determine if the examples below are similar by side, side, side. If yes, write the statement. What we have here is 3, 4, 5, and then 6, 8, 10. Do you see any similarities in between the two? Very good. The small triangle could be multiplied by 2 to get the large triangle. So you know right from the start that these are similar triangles. It's not always going to be so obvious, so you're going to have to check sometimes. And the way that you could check is this way, like the way we did yesterday. Like you would do 3 over 6, 4 over 8, and then 5 over 10. And again, you could also reverse it and do 6 over 3, 8 over 4, 5, 10 over 5. But when you reduce all of these, 3 over 6, that's 0.5. 4 over 8 is 0.5. 5 over 10 is 0.5, or 1/2, which means that the sides are proportional. Now let's say they are similar, and let's write the similarity statement. So I'm going to start with PQR. Can you complete the statement? So PQR, I went from blue to red to green, right? What would it be? SDU. All right, I would like you to try example 4. Yeah, are they similar or not similar? No? All right, let's take a look. So we have 30, right? 30 over 24. We have 35 over 28 and 32 over 25. So if we take a calculator and we divide each one, let's see what we'd get. All right, with your help, 30 over 24 is 1.25. What about 35 over 28? 1.25? Got 128. 35 over 20. Oops, sorry. All right. 35 over 28. I got 1.25 as well. Yeah. And then what about 32 over 25? 32 over, say it one more time. 1.28. So notice how close this was. I mean, we would say this is almost similar. 1.25, 1.25, 1.28. Because of that, 1.28, we're going to say that they are not similar. And when they're not similar, you don't write the similarity statement. So I'm just going to write here, no. All right, let's take a look at the third and final theorem that we have here. Side angle side. So if two corresponding sides are proportional and the included angle is congruent, then we could say that the triangles are similar. So let's take a look. So here, this notation would mean that the angles are congruent, right? They have the same markings. That means angles are congruent. So now we're checking 8 over 6 and 20 over 15 and see if they reduce to the same fraction. So 8 over 6. Can somebody tell me what does that reduce to? Yeah. 8 over 6 is? All right, I'm just going to reduce it then to another fraction, 4/3. 20 over 15, if I divide both numbers by 5, what do I get? 4/3, yeah? So the sides are proportional, the included angle is the same, we could say, yes, these two triangles are similar by side angle side. So I'm going to say triangle JKL is similar to what triangle? JKL goes with what? MN, is that P? MNP. All right. Let's take a look at question 6 together because it looks a little different from question 5. Here you still have two triangles, but it's like the smaller triangle is inside the larger triangle. And it looks like the included angle is the angle that they share, angle A. So what we're checking is, we can check, does 15 over 25, is it the same as 12 over 21? Because here is the short side to long side, short side to long side. Can you check and let me know? It said here 4 over 7. Okay. Maybe it's not as easy to see whether they're the same, but I think 3 over 5 is not the same as 4 over 7. To be more specific, 3 over 5 comes out to be 0.6, and 4 over 7 comes out to be very close, 0.57. So one would almost think that, you know what, they are. You know, they look similar. They should be. It's like stretched out. But it looks like one side was maybe stretched out a little more, like this side was stretched out a little more than the other side, which is the reason why they are not similar. Let's practice by doing questions 1 and 2. I'm going to give you some time, about 3 minutes, and then we'll check. So when we match them up, I just went small side to small side, long side to long side, and looks like they both reduce to 1 over 3. And they both reduce to 1 over 3, and in addition to, they do have an angle that is congruent, which means which theorem would prove that these two triangles are similar? SAS, so side, angle, side. We're going to say triangle EFG is similar to the triangle what? EFG, red to green to nothing. So RST. RST. What did you get for the second question? Yes or no? Is it similar or not similar? I mean, if it was going to be similar, it looks like it would be side, side, side. But we can't just say that it's side, side, side. Instead, you got to check each pair of sides to see if they're corresponding. And let's use the same method as number 1. We'll just do short side, which is 22, to short side, which is 16. What's the medium side? 28. What's the medium side of the other triangle? 20. And finally, long side is 35 over 25. And now we compare. When you divide 22 by 16, what do you get? 1. I'm going to put 1.375 because we have to be accurate. We have to be accurate. 28 over 20, what does that reduce to? And 35 over 25? I believe it's also 1.4. So because of this little difference right here, we're going to say no, they are not similar.